Hey, Chemistry 12. Hope you were able to watch the how to change and increase and decrease solubility video lecture video. Here's your worksheet. This is going to be your answer sheet, I guess, as well. So hopefully you've had a chance to do this, and now you're looking for some answers. Anyways, let's go through this. So here is a worksheet right here. We have consider the following equilibrium. We have silver iodate makes silver ions and iodate ions. Um, now, if you look on your table, you can find silver iodate. It is, let's see, find it right. So here's my data booklet. And there is right there 3.2 times 10 to the minus 8 is silver iodate. So let's go back to our thing. So what would happen if more silver was added? Okay, so here it says, what would happen if more silver ion was added? Now this whole thing is all uh, equilibrium, shift left, shift right kind of stuff, but with solubility. So if we had more silver was added, so if I'm going to write this formula out again, AgIO3 forms an equilibrium with Ag plus IO3 minus. Now, if I were to draw showing this going up, so in other words, more silver was added, what's going to happen is that this thing is going to be shifting to the left. So remember when we talked about the car steering wheel? So we should be thinking of our car steering wheel right here. Here's the center, or in other words, where it's going like this. So silver is going up. So I'm going to go back to my black pen. So silver is going up right here. And so therefore it's going to make us turn left. So it's going to, so what would happen if more silver was added? Well, it's going to shift left, shift left. Now, we don't really care about the whole shifting left thing, but we care since it's shifting left, it'll be making more AgIO3. Okay, so it's going to shift left, makes more AgIO3, or in other words, since it's a solid, makes more precipitate. Okay, or in other words, it decreases solubility. So, and that's so these are the two big answers that we'd be looking for. Makes more precipitate or decreases solubility. So we add more silver ion, forces it to shift left, is going to have more stuff is going to precipitate out of this. And that's our answer to the first one. Now, here's the answer to the next one. We have AgIO3. We're going to be working off the same equation. Ag plus IO3 minus. Again, we're going to add more iodate ions, so this is going to go up. It's going to be shifting left. So it shifts left. An exact same thing. Makes more precipitate, decreases solubility. Now, what would happen if NaCl was added? So the first thing we should think about is that NaCl is going to be Na plus Cl minus. Now, Na is not going to react with anything. So what we call this is Na is what we call a spectator. It's not going to react with Ag. It doesn't react with IO3. Now, I know it doesn't react with anything because of this table right here. So if I go back up here, it says way into here, Na with everything is soluble. So it's not going to be reacting. So Na is not going to be reacting. So what about Cl? So let's go back to our table and we're going to find out where Cl is. So here is Cl way over here. And it says Cl is going to be reacting with Ag plus, and it's going to be forming a precipitate. It has low solubility. So what is going to happen is that we take our formula again, AgIO3, okay, Ag plus plus IO3 minus. So Na is going to be doing nothing, so we can pretty much ignore it. So Cl is going to be combining with this. So this is going to be, this Ag plus is going to combine with this Cl minus, and it's going to turn into AgCl. So what is happening to this thing is that since this Cl is going to be using this Ag up, it's going to effectively decrease the concentration of Ag. Since it decreases the concentration of Ag, again, steering wheel, this side is going down of the steering wheel. Here's the center of our steering wheel. This side is going down, so it's going to be shifting right. So it is going to shift right. Okay, because, and the reason why it's shifting right is because Cl is decreasing the concentration of silver ions, Ag plus ions. So it shifts to the right, and that means when it shifts to the right, this stuff right here, this silver iodate, gets used up. More of it starts to dissolve, and starts to dissolve and turn into Ag plus and IO3 minus because it's shifting to the right. So what it's going to do is going to, let's switch my pen back to something. So it's going to increase solubility because it shifts right. Okay. So what would happen is that, what would you see if you actually did this? You would see AgIO3 right here start to dissolve more, and you would see the precipitate to start to go away. Now, what you would see though is that you would start to see an increase in the amount of silver chloride precipitate starting to form. But we're not really interested in silver chloride precipitate. We're interested in what is happening to this concentrate, or this thing right here. And so it's going to increase this solubility. Okay. You have, next question right here. You have water that has been contaminated with lead 2 ions. And I need to, before I send this out, I'm going to superscript that for you to make it a little bit nicer looking. What would be the best chemical to remove lead? NaCl, NaBr, NaI. Please explain. So first off is that all of these NAs are just going to be spectators. So essentially the question that we're asking, what is going to be the best one to use? Okay. So we're going to go back to this table right here. Go down, and we're going to look up the lead section, and we find PBBr, which is, let's see. Oh, I can write on this thing. Okay, we find PBBr, which is PBBr2, which is 6.6 times 10 to the negative 6. We have lead 2 chloride, 1.2 times 10 to the minus 5, and lead iodide, which is 8.5 times 10 to the minus 9. So since this one right here has the lowest KSP value, that means it'll be forming a precipitate the easiest, and it'll be taking out more PB than these other ones right here. So this right here, and what it means is essentially, say if you only had 10 grams of NaCl, let's say you had 1 mole of NaBr, 1 mole of NaCl, and 1 mole of NaI. Okay, so this is our things that we're adding. Again, we know that Na is a spectator, so we can ignore it. So if we had 1 mole of all these things, this one is going to be the most effective. It'll be removing most of the lead, and it's because this has the smallest KSP. And so if we go back to our question right here, okay, and we're going to say that this one is best because smallest or lowest KSP, therefore will remove more Pb2 plus per mole. So what that means when I say per mole is like, say if you had like lead contaminated water and you had like 1 gram of NaI, okay, and for here you had 1 ton of NaCl. Well, the 1 ton of NaCl is going to be doing a better job, but per mole the NaI will be doing a better job. Okay, next question right here. We have considering the following equation, and here it is right here. So we have silver chloride, and yeah. What would happen if, oh, and I made a little mistake right here. Oops, we should have a equilibrium kind of arrow right there. What would happen if you added PbNO3? Now, again, we talked about how Na is a spectator, and NO3 is also going to be a spectator, and here it is right here. So nitrate, or NO3 minus, with everything is soluble. So NO3 is always going to be a spectator in these solubility equations. So going back here, we know that this thing is going to be soluble. So essentially, what it's saying is what happens when we add Pb2 plus to this thing. So again, AgCl, Ag plus Cl minus. We're going to go back to this table right here again. And then what we notice is that if you have Cl and Pb, it's low soluble. So what if you added Pb into this? It's going to form PbCl2. And that means it is going to be effectively decreasing this concentration. And so therefore it's going to shift right. Because again, steering wheel, this side is going down. That means we're turning to the right. It's going to shift right. What else? It's going to increase AgCl solubility. Okay. So that means more AgCl will dissolve. Okay. Now, this is a tricky question. This is the kind of question you put on because to kind of trick a few people. What would happen if you added AgCl? Now, AgCl is solid, right? If you added AgCl into this, everyone wants to say it's going to shift to the right and it's going to increase the solubility, but it's not. Since it's a solid, it is low soluble. This is already a saturated solution. If you had a beaker right here and you had some Ag plus dissolved in the liquid, you had some Cl minus dissolved in the liquid, and you had some solids, some Ag solid right down here. I'm just going to change my pen color really quick. You had some Ag Cl solid down here. So here's your AgCl solid. Now, if you threw in some more AgCl solid, what's going to happen is that it's just going to sink to the bottom and stay there. It's just going to, so you're not going to have more dissolving or any of that kind of stuff. So it's a solid. If you added a solid into an equilibrium equation, it's not going to do anything. So what would happen if you added AgCl? Nothing. Okay, you're adding a solid. You're not increasing the concentration of Ag. You're not increasing the concentration of Cl. Um, so it's a solid. It's not going to be affecting the equilibrium. Okay, one can make the argument that it's going to increase the reaction rate by creating a larger surface area, but and that's probably true. It could increase the reaction rate, but if you're increasing the reaction rate in the forward direction, it's also going to increase it in the reverse direction, and so therefore, still nothing is going to happen. Okay, now next question: what would happen if you added NaCl? We've talked a bunch about it. Na is a spectator, so we're going to ignore it. So here we have AgCl turns into Ag plus Cl minus. We're increasing the concentration of Cl minus, so this is going to go up. That means on our steering wheel, this side is going up. Okay, that means we're going to be turning left or shifting. Shift left. And that means we're going to be making more precipitate. So making more precipitate, or in other words, we're going to decrease solubility. Okay. What would happen if you added AgNO3? Again, we talked about this. NO3 is a spectator. We have AgCl, Ag plus Cl minus. We're going to be increasing this. Okay. That means it's going to be shifting left again. Shift left. And that means we're also going to decrease solubility. That's our answer. Here's an interesting one. NaBr, again, Na, spectator. Okay, let's write our formula out. Oops. So we're going to be adding Br. Let's take a look. So here we see that Br plus Ag has low solubility. Okay, so we're going to go back that. Now we know that Br is going to be reacting with Ag. And so what's going to happen is that Br right here is going to react with Ag, and it's going to form AgBr. And so what that means is that it's going to decrease the concentration of Ag. It's going to decrease the concentration of Ag. So on our steering wheel, this side is going to go down. And so that means we are going to be shifting right. And that means we're going to increase solubility. Okay. Okay, let's go back to a black pen. Okay, what would happen if you added NaNO3? We've talked about this a ton. Na, spectator ion. NO3, also a spectator ion. So what happens if you added something that is completely spectator ions? In other words, Na doesn't react with anything, NO3 doesn't react with anything. What's going to happen? Well, no reaction, so nothing. And you could say, if you want to get more technical, you could say both are spectators. Make a little divider for this one. Both are spectator ions. What would happen if you add KOH? Okay, so we have this AgCl, Ag plus Cl minus. So we're going to add KOH. Let's go to our table. Okay, so first let's look at K. So here we found K right here, plus anything. So we know that K is a spectator. Okay, so let's go back to this thing right here. Just cross that off our list. K is a spectator, so nothing. Let's go back here. Look up OH now. So I go down and I find OH right here. Okay, now it's going to be reacting with the silver right here because silver, or Ag, is not an alkali ion. That is just your first column on your periodic table. And it's none of these things right here. So Ag is part of the all others group, and that means it's going to form a precipitate. So this OH is going to be part of the reaction. So we're going to go back here right now and say that OH is going to react with this one right here, and it is going to form AgOH. So what that is going to effectively do, just like our other ones, is that it's going to decrease the concentration of Ag. And that means, since it decreases the concentration of Ag, things are our steering wheel, it's going to go down right here. And so that means we're going to be shifting to the right. And so it's going to shift right. Okay, so it's going to shift right there, and that means it's going to increase solubility. Okay, so hopefully you got the right answers. And again, if you have questions, you can message me through Microsoft Teams. Other than that, once you feel ready, once you feel comfortable, attempt the quiz. Okay, goodbye.